Hello, very welcome. And now we are continuing our discussion about CMOS compounding logic. In a previous module, if you are new here, you can see we have covered how we can implement compound logic using CMOS transistors. And in addition to that, today we see here we got the new expression, which is y equals to in the parenthesis A or B or C and D a bar, the complement of this whole expression. So how we are going to implement this is what we are seeing today. So to move forward, we know that we want to implement these expressions A or B or C. So OR means the NMOS transistors are in parallel to each other. So that's three inputs, A, B, C, and NMOS are parallel. Now you got the AND operation of with the D. So with this term, you are ANDing D. Therefore, you have this fourth transistor to which the input is D in series with the above. Once that is done, what you need now, the PMOS transistors, which are obviously the complementary to NMOS. So therefore, since the NMOS are all in parallel here, A, B, C, therefore the PMOS with the inputs A, B, C are going to be in series. And now we will see in a moment, D input transistor NMOS comes in series with the parallel here. So D input PMOS transistor would be in parallel with this series branch. So which is what we see here. So D input transistor is in parallel with this one. Once you have got the NMOS network, which is a pull down network, you have got the PMOS network, which is a pull up network. We know what is pull up and pull down. So we'll see. You can see now I have placed a pull down network, or simply say NMOS network right over here. Then on top, I have placed this network, which is of PMOS. Now, time to connect VDD as shown, ground as shown, and there is this green output Y. So this is how you implemented the compound logic using CMOS transistors, which is Y equals to A or B or C in parentheses and D, and then take a complement of it. So output Y is equal to 1 right over here. Output Y is equal to 1 when A or B or C and D will be uh, activated accordingly. So you can just put all combinations you want to see, A, B, C, D, to the inputs, and accordingly you can see the output is available. So how this network output will be one, it means the pull-up network will connect the output Y to the highest supply voltage VDD, and output is zero. It means pull down network right over here will pull the output back to the ground. So that's how the pull up and pull down will work. So just use any combination of input, let's say 0 1 0 1, something like that, and see how the switches will function, and how whether the output gets pulled up to VDD or output gets pulled down to the ground. Okay, so that was an exercise to understand the compound logic. Hope you found this model useful. If you did so, share it with others for wider reach, and stay tuned for more. Till then, wish you very happy learning.